Hello and welcome back to the course on deep learning. All right, today we're talking about the activation function. Let's get straight into it. So this is where we left off previously. We talked about the structure of one neuron. So there it is in the middle. We know that it has some inputs values coming in. It's got some weights. Then it adds up it calculates the weighted sum of those inputs and then applies the activation function. And on step 3, it passes on the signal to the next neuron. And that's what we're talking about today. We're talking about the value that is going to be passed over. So we're talking about the activation function that's being applied. So what options do we have for the activation function? Well, we're going to look at 4 different types of activation functions that you can choose from. Of course, there are more different types of activation functions, but these are the predominant ones that you'll be hearing about and that we'll be using in this course. So here is the threshold function. This is what it looks like. So on the x-axis, you have the weighted sum of inputs. On the y-axis, you have just the values from 0 to 1. And basically, the threshold function is a very simple type of function where if the value is less than 0, then the threshold function passes on 0. If the value is more than 0 or equal to 0, then threshold function passes on a 1. So it's basically kind of like yes-no type of function, very, very straightforward, very kind of like rigid type of function, either yes or no, no other options. So there you go, that's how it works, very simple function. Let's move on to something a bit more complex now. The sigmoid function, very interesting formula that we have here, you'll see just now. There it is, 1 divided by 1 plus e to the power of minus x. Whereas in this case, of course, x is the value of the summed of the weighted sums. And so this is what the sigmoid looks like. It's a function which is used in the logistic regression, if you recall from the machine learning course. So what is good about this function is that it is smooth. Unlike the threshold function, this one doesn't have those kinks in its curve, and therefore it's just nice and smooth, gradual progression. So anything below 0, it just like drops off. Above 0, it approximates towards 1. And this sigmoid function is very useful in the final layer, in the output layer, especially when you're trying to predict probabilities. And we'll see that throughout this course. And then we've got the rectifier function. Rectifier function, even though it has a kink, is one of the most popular functions for artificial neural networks. So it goes all the way to 0. It is 0, and then from there, it gradually progresses as the input value increases as well. And we'll see that throughout the course. We'll see that in other intuition tutorials, and we'll also see that how we use this function in the practical side of the course. And I will comment on this a bit more in a few slides from now. So just remember that a rectifier function is one of the most used functions in artificial neural networks. And finally, we've got one more function that you will probably hear about. It's the hyperbolic tangent function. It's very similar to the sigmoid function, but here the hyperbolic tangent function goes below 0. So the values go from 0 to 1 or approximate to 1 and go from 0 to minus 1 on the other side. And that can be useful in some applications. So we're not going to go into too much depth on each one of these functions. I just wanted to acquaint you with them so that you know what they look like and what they're called. If you'd like to get some additional reading, then check out this paper by Javier Glorot, called Deep Sparse Rectifier Neural Networks, 2011 paper. And there you will find out exactly why the rectifier function is such a valuable function, why it's so popularly used. But nevertheless, for now, you don't really need to know all of those things. For now, we're just going to start applying them. We're going to start using them more and more and more. And so when you feel comfortable with the practical side of things, then you can go and refer to this paper, and then you will be able to soak in that knowledge much quicker, and it'll make much more sense. So, but just keep this in mind that when you're ready, when you feel that you're ready, then you can go and refer to this paper and get some valuable knowledge from there. So just to quickly recap, we have the threshold activation function, which looks like this, the sigmoid activation function, which looks like this. We have the rectifier function, and we have the hyperbolic tangent function. And now to finish off this tutorial, let's quickly do a few exercises. So we'll just do two quick exercises to help that knowledge sink in. So first one is, we've got an example here of a neural network with just one neuron and then right away the output layer. And the question is, assuming that your dependent variable is binary, so it's either 0 or 1, which threshold function would you use? So out of the ones that we've discussed, we have the threshold function, the sigmoid function, the rectifier function, and we've got the hyperbolic tangent function. In their raw forms, which ones would you be able to use for a binary variable? Okay, so the answers here are, there's two options that we can approach this with. So number one is the threshold activation function. Because we know that it's between 0 and 1, and it gives you a 0 under certain values, and then otherwise it gives you 1, so it only can give you 2 values. It fits perfectly, fits this requirement perfectly, and therefore you can just say y equals the threshold function of your weighted sum, and that's it. And in the second case, what you could use is the sigmoid activation function. It is actually also between 0 and 1, just what we need, but at the same time, you want is just 0 or 1, right? So it's not exactly what we need, but in this case, what you could use it as is the probability of y being yes or no. So we want y to be 0 or 1, but instead we'll say that the sigmoid function, sigmoid activation function, tells us whether it tells us the probability of y being equal to 1. So basically, the closer you get to the top, the more likely it is that this is indeed a 1 or a yes rather than a no. And yeah, so that's very similar to the logistic regression approach. And those are just two examples of if you have a binary variable. And now let's have a look at another practical application. Let's have a look at how all this would play out if we had a neural network like this. So in the first input layer, we have some inputs. They are sent off to our first hidden layer, and then an activation function is applied. And usually what you would apply here, and what you'll see throughout this course, is we would apply a rectifier activation function. So it would look something like that. We apply the rectifier activation function, and then from there, the signals would be passed on to the output layer, where the sigmoid activation function would be applied, and that would be our final output, and that could predict a probability, for instance. So this combination is going to be quite common, where in the hidden layers we apply the rectifier function, and then in the output layer we apply the sigmoid function. So there we go. Hope you enjoyed today's tutorial. Now you are quite well versed in the 4 different types of activation functions, and you will get some hands-on practical experience with them throughout this course. We'll be using them all over the place, so you'll get to know them quite intimately, and you should be quite comfortable with them. But for now, this is the knowledge that you need to progress and understand what is going to be happening further down in this course. And on that note, I will look forward to seeing you next time. Until then, enjoy deep learning.